Hey, and welcome to Math in a Class with ClassCalc. My name is Dan, and today we'll be digging into a special physics problem. We got here in front of us a one-dimensional kinematics problem. Basically, guy throws up, or actually girl, throws a ball up into the air at 15 meters per second, and the question is asking us to calculate how high it goes, as well as how long the ball will be in the air before it comes down. So we'll go right on ahead and start with part A. So what I like to do with physics is, first of all, lay out all of the potential equations we might be using. And so I've actually laid out the kinematics equation right here. It's always good just to have them in front of you so you kind of know what tools you have at your disposal. Now, we're told that the initial velocity, or v naught, is going to be 15 meters per second. And in the first part, we're actually looking for height, which is going to be some sort of displacement, which is going to be a delta x here. And so the first part of a problem is to kind of look at the reference or the scope that you're going to use. So what are we looking at? Are we looking at the ball going from leaving the hand to the maximum height, or the ball going to the maximum height and then falling back down? There's a lot of different scopes you could take into consideration. In this case, we're looking for how high the ball goes. So we probably want to, the way to prioritize the way to decide what scope to look at is to first off choose situations in which you have as much data as possible, and then choose situations which will give you the answer you're looking for. So for example, we're going to look at from when the ball leaves the hand, point A, until it reaches the maximum up here, right, point B. And the reason we do that is because when the ball leaves the hand, we get information on the velocity, and that's something we want. And what we're looking for is when the ball is at its maximum height, which is why we choose that as point B. So that's really what we have as our scope, from leaving the hand to reaching the maximum height. That's step number one. After you've chosen the scope, step number two is to kind of choose what equations you're going to use. And for that, we use a similar process of kind of seeing what data we have and seeing what data we're looking for. So we have V naught, and we're looking for delta x. So anything that will relate those two will give us what we need. Now, a caveat to mention is that you want to also use an equation that minimizes any other variables, because the more variables introduced into an equation, the more complexity you're going to have. And so, for example, equation number 3 here has both delta x and v naught, but it also has t, and that's going to make things a little more difficult because we don't know how long it's going to take to leave from when the ball gets from point A to point B. We don't know how long that'll take. So a much easier way to go about it will be to actually use equation 4 here, where we have the initial velocity, and we have the acceleration, which is going to be gravity, and we have the delta x, right? We're looking for the delta x. That's fine, right? And we actually do have the final velocity, because we know that at the maximum height, when the ball goes from moving upwards to moving downwards, the velocity is going to be 0. So we're going to go ahead and write that out. So v squared equals v naught squared plus 2a delta x. Plug in the variables. That's 0 squared equals 15 meters per second squared plus 2 times, and now gravity is going to be negative 9.8 because we took velocity, we took upward to be the positive direction, so negative 9.8 meters per second squared, times the delta x, which we don't know. Next, we just do some algebra. So we move the 15 over to the other side, negative 15 squared meters per second. Well, actually, that's going to be meters per second squared. Over 2 times negative 9.8 meters per second squared. Yeah. So we got our handy calculator here now on the right. And we're going to go ahead and plug that in. So that's going to be negative 15 squared over 2 times negative 9.8. So negative 15 squared over 2 times negative 9.8. Simple as that. Press enter. We got our answer of 11.48. Our displacement is going to be 11.48 meters. And to check your units, we know that's right because we got meters squared per second squared. And so we're going to ultimately be left with just meters. Now we're going to solve part B, right? So same scenario. How long the ball will be in the air before it comes back down to the hand. So there are actually several ways to do this. But the most intuitive way is to think of it as taking the scope as the ball going from A to C. Because if we just calculate that time, then we basically have our answer. And so again, right, we now have V0 and delta x. So that's what we have. And we're looking for t. So to solve this, we could actually use any of the first three equations up here. But again, we look at the variables we have. We look at the variables we're looking for. And then we pick the equation that will have the lowest complexity and let us get to the answer as quickly as possible. By lowest complexity, we mean the least number of variables. We can use number one in some creative ways. But we're actually, for the sake of this problem, we're going to go ahead and use equation number 3 here. And now we know our delta x is actually going to be 0 in this situation because A and C are at the same height. So we have 0 equals 15 meters per second times t plus half times negative 9.8 meters per second squared times t squared. Now solving for that, I'm actually going to do negative 9.8 times 0.5, which gives negative 4.9. So we have negative 4.9 t squared plus 15t equals 0. Now we just factor out the t. We get t times negative 4.9 t plus 15 equals 0. And our two t's is, the first one is t equals 0. The second one is going to be negative, so it's going to be t equals negative 15 over negative 4.9, which is going to be negative 15 over negative 4.9, which is going to be 3.06. 3.06, that's 06 seconds. Now you may be wondering, is it going to be this first t or this second t? And the answer is that the correct answer is the second t right here. Since the first t corresponds to the t, because basically what this equation is saying is at what time will x equal 0, right? At what time will our height be 0? Now, it'll be 0 at t equals 0, right, when it leaves your hand, but it'll also come back to 0. That's what we're looking for, right? When it comes back to your hand, and that'll be 3.06 seconds later. So that's the answer to question number B. Well, that's it for this week's math problem. For questions or comments, please feel free to reach out to info@classcalc.com. And make sure to let us know in the comments below what you might want to see in the future weeks. We always love to hear from you guys.